Okay, so today we will start off with geometry. Okay, now we'll try to cover almost all the important properties. Then I will discuss all the equations which is required. Then also then after that I'll discuss the method in which you can solve the problem without using any of the equations. Okay, so we will start off with triangles, which is the first polygon. Then we will move on to quadrilateral, then pentagon, hexagon, octagon. Okay. Then finally we will cover circle. Okay, then associated property. Then we will discuss about polygon, in a polygon like circle and a triangle. Then we will discuss like circle and a square, right? Or like this. All these things will be covered in the order. Okay, so let's start off with triangle. We will discuss some of the important properties which you already know, so or some important formulas starting with. So if you have a triangle, okay, if you have a triangle A, B, C, the three sides are known. What is the area? You know that it is root of S into S minus A into S minus B into S minus C, right? Where S is equal to the semi-perimeter, which is A plus B plus C by. In case if you know the height, okay, so if the height is known to you and if this is a base, okay, so if you know the base and the height, then you have a faster method, half BH, okay, you will get the area. So if the height is known, you will use this. Height and the base is known, you will use this. If three sides are known, if you don't know the height, you will use this. Okay. Now, if you are getting this, okay, three sides A, B, C, also they are giving you the circumradius. That means in the triangle, it circumscribes. Okay, a circle is there. So basically in the triangle there's a circumcircle. Okay, so circumcircle is there means you will get the circumradius. Okay, so let's keep circumradius as R and this is ABC, right? So here you have given three sides, so you can either use root of S into S or root of S into S minus A into S minus B. Otherwise, since R is given, you can use this also. ABC divided by 4R, you will get the area. Okay, now instead of circumcircle, if there is an incircle, they will be giving you an in radius, right? R. So this will be A, this will be B, and this will be C. The sides are given, and in radius is given. Then your answer is R into S, where S is the same semi-perimeter that we have discussed, A plus B plus C by 2. Okay, so we have discussed about four methods of finding the area. Root of S into S minus A into S minus B into S minus C, where the three sides are given. Now here S is the semi-perimeter. Or if base and height is given, half into B into H. Now if the three sides are given, the circumradius is given. So what is the answer? ABC by 4R. Now if three sides are given and in radius is given, so your answer is R into S, where S is the semi-perimeter, R is the in radius. Here R is the circumradius. ABC are the three sides. Okay, so these are the various methods of finding the area. Now what if it's an equilateral triangle? All the sides are equal, right? So this will be A, this will be A, this will be A. So now how will you find the area? So what you can do is you can drop a perpendicular here, right? So in right angle, if you draw this perpendicular bisector, it will bisect. Okay, if you drop a perpendicular, it will bisect the base. So this will be A by 2 and this will be A by 2, right? So you know this is A by 2, this is A. Can you find the height? Yes. So what will be the height in an equilateral triangle? If one side is given, can you find the height is a question, right? So height is equal to A square minus A by 2 square, right? So you'll get it as root 3 by 2A. Why? Because you will get it as 4A square minus A square divided by 4, right? There is nothing but 3A square divided by 4, right? When you take the root of it, root 3 by 2A. This is the height. So you got this as root 3 by 2 into A. So if one side is given, you can find the height, root 3 by 2A. So if one side is given, that means base is also given, right? So base is given A and height you can find out as root 3 by 2A. Then what is area? Half into base is A into root 3 by 2A. So this will be root 3 by 4A square. So what is the area of an equilateral triangle if one side is given? Root 3 by 4A square. If one side is given, what is the height? Root 3 by 2A. Okay, so you can get questions based on area also, and you can get question on the base of height also. So if one side is given, height is root 3 by 2A, area is root 3 by 4A square. Now what do you mean by this concepts like orthocenter, centroid, circumcenter and incenter? What are they? Or what do you mean by altitude, median, perpendicular bisector and angle bisector? What is median? If it's a triangle, okay, median divides equally. Okay, so this is a median divides equally. Now what is the altitude? Altitude you drop from the vertex only, but you cannot say this and this is equal. Okay, the special case can be where it can be equal, but you cannot say it is equal. So this is also a possibility, right? This is also a possibility. You're dropping it from the vertex, so you cannot say this and this is equal, right? So this is what altitude. But what is median? If this is the case, it have to divide equally. Okay. What is perpendicular bisector? Perpendicular bisector will bisect, right? So this has to be equal. Now, in this case, it will go like this also. So the condition is this has to be equal. Now what is angle bisector? Angle bisector, if this is 30, angle bisector will divide equally. That is, this is 15 and this is 15. Now, if you take an equilateral triangle, if you draw the median, okay, if you draw the three median, will meet at a point. This point is the centroid. Now the speciality is in equilateral triangle, centroid divide the median in the ratio 2:1. So basically this is 2, this is 1. So if that is 2 and this is 1, everything will be in the same ratio. This is 2, this is 1. Okay. So basically this is 2 and this is 1. Now by keeping this centroid as the center, if you draw an in radius, okay, if you draw an in radius means it has to touch, right, the triangle, this side and this side, right? If you draw an incircle, it will go like this. So what will be the radius? This is a radius, right? This is a radius. Now let's see, if you keep this as a center, if you draw a circumcircle, what will happen is, what is the radius? This is the radius, right? So if you see this together is the height, right? This is the height in an equilateral triangle. So what you can understand is, okay, so this I already told you, this is 2 and this is 1, divide in the ratio 2:1. So the radius of circumcircle and incircle is in the ratio 2:1. You understood? So obviously the areas will also be in the ratio 2:1, right? Now the height is in the ratio 2:1. So if you need to find the radius of this, so if one side is A, we know that height is root 3 by 2A. We know height is root 3 by 2A, right? Now if you see, the circumradius will be in the ratio of, see, circumradius and inradius is the ratio of 2:1. So total is the height, right? So height is divided in the ratio 2:1. So what will be the ratio of, what will be the radius of circumcircle into 2 by 3, right? Because 2:1 is the ratio. So 2 is the circumradius. So this get cancelled. So you'll get A by root 3. This also will get cancelled. So the radius, now what all things we got is, the radius of circumcircle or the circumradius is A by root 3. Then what will be the radius of the incircle? We know it will be half of it, right? So A divided by 2 root 3. So what all things we got? If you have an equilateral triangle, one side A is given, okay? What all things we got? We got the height as root 3 by 2A, right? So we got this. We got the area as root 3 by 4A square, because this we know A and this we know root 3 by 2. So we can find it. We got the circumradius, okay? So circumradius as A by root 3, because we know that height we are dividing in the ratio 2 by 3, right? Now in radius is A by 2 root 3, because in radius is, if you divide the height in 1 with 1 by 3, you will get the in radius, right? So height is root 3 by 2A. If you do this 1 by 3, this will become root 3. So A by 2 root 3. So these are the 4 things which you can keep in your mind with respect to equilateral triangle. Now if you move on to right angle triangle, you can expect questions from right angle triangle. So basically one thing that you need to keep in mind is, you will get questions from 2 types of right angle triangle only. The reason I tell you, see, the 2 types are, this is 60 30, obviously this is 90, and the next will be 45 45 90. This is 45, this is 45, and this is 90. Okay, now if you take any questions, it will be on the basis of this ratio only. Okay, the reason is, see, now I give you the method of finding the answer also. So opposite of 30 is 1, opposite of 60 will be root 3, opposite of 90 will be 2. This is the ratio always. Okay, now 45 opposite it will be 1, this will be 1, and this will be root 2, because we know we are applying Pythagoras theorem. Okay, so this is what you need to keep in your mind. Now if you get questions like this, okay, see, you have a pole, you need to find the length of the pole, basically that is a question. Now now you are standing at the distance of, let's say, root 3, okay, or you are standing at the distance of 3, okay. Now you are making an angle from here of 30 to the top of the pole, right? So this is 30 which is given, so we know that this will be 60 if you make a triangle, and the opposite of 60 is given as 3. So the question will be, what will be the height? It will be root 3, because it has to be the ratio, right? Or they can ask you a different question. A ladder leans against the wall and it touches the ground and making an angle of 30, or from here they are making an angle of 60. So obviously this is 30 and wall means this is 90. Okay, now what you will get is this length, the height of the wall may be given, maybe this is 10. So what will be this? 10 root 3. Very easy, right? So in case of 45, this questions will be easy. If this is given as 30, this has to be 30. Now why I told you that these are the two triangles possible? Because see, otherwise you need to apply this sine 45, sine 30, because sine, see here 45, what values are given? 30, 45, 60, 90, right? These values, sine value, cos value, tan value, etc. you can remember. But sine 15, sine 20, sine 25, sine 30, sine 35, etc. is not expected from you. That's why you will get these two triangles only. Now, what about if you draw a circumcircle on a right angled triangle? What will be the radius? Half of the hypotenuse. You will draw like this, right? So this will be the radius. So that is actually half of hypotenuse. So I have seen this question in a previous paper. It was like this. You have a right angle triangle, okay? So right angle triangle, and like A, B, C is a right angle triangle. D is the midpoint of AC, okay? D is the midpoint of AC, and they asked this length BD. This length is what asked. What is the answer? It is, so, and this obviously AC is given, whatever it is, maybe let's take it as 10, okay? So whatever it is not important for us. The property that we have learned is what we are going to use here. So what is the length? It will be equal to, this length is what asked, right? What is BD? See here, D is the midpoint, right? So you need to remember this property that I have discussed. So basically if you draw a circumcircle by touching the 3 points, okay, this is not correct, but if you draw, what is this? This AC is actually the diameter, right? So AC is the diameter and D is the midpoint, means AD is what? AD is the radius. Similarly, DC is also the radius. So what is BD? BD is also the radius only. So what is the answer? What is the length of BD? BD is 5. Okay, so if AC is 10, BD is actually 5. So the radius will be half of hypotenuse. That is the property. So here BD is nothing but the radius itself. Okay, so BD is the radius here. So okay, so otherwise also you can relate it to one property that you will be learning later. I'll be discussing in short. See, if this is the diameter, okay, now if you draw any angle which is touching any part of the circle, that will be 90 degree. So this is 90. If this is also 90. So if this is 90 and if you are drawing a circumcircle, obviously this is the diameter. This hypotenuse will be the diameter. So this is going to be half of it. Okay. So if the question is asked like this, BD which is asked, okay, so answer is 5. They can also ask you what is the radius if you draw a circumcircle, then also the answer is 5. Now let's look at some important properties that you need to use in the questions related to geometry. Okay, so I am discussing only the basic properties, and any property or any question if it is asked, you can derive everything from the basic property that you are going to learn here. Let me start off with the first one that I have already discussed. You have a circle, okay, so this AB is the diameter. AB is the diameter. Now if you draw like this angle will be 90 degree. So if you put a point on the circle, anywhere on the circle, if you put a point here, if you draw like this, then this will be 90 degree. If you put a point on the circle anywhere, you just draw like this, that angle will be 90 degree. So the idea is this has to be diameter. So keeping the diameter on one side, and if you join any point on the circle, you will get a right angle triangle. Okay, so keeping the diameter, you join any point on the circle, you will get a right angle triangle. So keeping the diameter, you will join any point, this point, okay, you will get a right angle triangle. Now one more case, if you take a circle and let's take this as a diameter, so let's take a cyclic quadrilateral. Okay, so if you consider the cyclic quadrilateral, so this will be 90 and this will be 90, so this two angle, if you add, that is 180. Okay, so if you put this as A and this is B, A plus B is equal to 180. Okay, that is obvious. Cyclic quadrilateral is what we are discussing. So basically you have flipped it over, right? So you have one here, so you just flipped it to this side, so obviously this is going to be 90 and total is 180. Now next property is, take a circle and let's consider the secant. AB is the secant. Okay, AB is the secant and O is the midpoint, so you join a line from the midpoint to secant. Okay, so you drop a perpendicular from the midpoint which is touching the secant and name it as OM. So what is AB? AB is the secant. So if you draw the perpendicular to bisect the secant, this length and this length will be equal. So AM is equal to BM. AM is equal to BM. That is the third property. One more property that is basically an extension of the same thing only. So take a circle, let's keep O as the midpoint. Now take two secants at the same distance. Okay, same distance. That means this distance and this distance both are same. Okay, so this and this is same. Now if you want, you can name it as MN. Okay, so ON and OM are same. OM is equal to ON. Now if that is the case, that means what? So from the center, two secants which are equidistant. That's what I mean by ON is equal to OM. Then what is the property? If that is the case, this length AB will be equal to CD. See, this is AB and this is CD. So two secants will be equal. So from the center, if you place two secants, one on the top and one on the bottom at the same distance, the length of both secants will be same. So obviously these two are equal and these two are equal. Okay, so we will be using these properties when we are looking for some problems later. Now another important property which you are going to use in most of the questions, many questions is going to be useful. So you get an external point. Okay, so you have an external point, let's mark it as P. Okay, you make a tangent. Okay, so this is touching at this point. Okay, so from center O, if you drop, okay, and this angle will be 90 degrees. So this is a right angle. Okay, so you can make a triangle, right angle triangle. Okay, so you will be able to solve many questions by using this very simple property, and I'll show you the application. In many cases we are going to use this property, so keep this property in mind. This is going to be very, very useful. So the moment you see a point outside the circle, you imagine that as a right angle triangle. How will you make a right angle triangle? Just drop a point from O. So this become a right angle triangle. So obviously if you know one side, we can find the other sides. I have discussed methods for that already. So you have seen methods that I have discussed in the square chapter. I have discussed, as well as in this session also I have discussed, right? So we will have different methods and that will be very easy also. So if you make this as right angle triangle, the method of finding other sides and angles is going to be very, very easy for you. Okay, so you are going to get a right angle triangle. So the moment you see a point outside, think of the possibility of getting a right angle triangle. How will you get it? Just drop a perpendicular from the center. Okay, so this is a point that you have seen. So you just drop a perpendicular, then you got a right angle triangle. Just join this two, right? Just join this two, you get a right angle triangle. So this is very, very important property, and this is what we call as tangent perpendicularity theorem. You don't want to know the name of the theorem and all, just remember this property, tangent perpendicular theorem. See, you have an external point here. The moment you see an external point, you can think of making a tangent, right? So it is touching here, and same way it is touching here. Okay, so this length and this length will be equal. So you have an external point, so you extend that point to touch the circle, you get tangent. So these two tangents will be equal. Now one important point which I need to tell you here is, if you just see the point, this is how you can solve many questions. See, from the center, let's keep this point as M or O. What I told you in the previous property, just drop a perpendicular here like just extend this line from the center. So what you get here 90 degree. So we will be using this property in many cases. Okay, so don't forget this. We are going to use this in many questions. So this angle will be 90 degree. So this length and this length will be equal, and which is known in most of the cases. Why? Because this is nothing but the radius. This is nothing but the radius, and we know this two will be equal. And if you know one among this, or if you can find one among this question is going to be very, very easy for you. So we are going to discuss about this when we discuss about the questions. Okay. So what you are getting here is actually a kite. But what I have started with a point. So what I have done, if you remember, I just told you have an external point. Then join this, this two length will be equal. Then from the previous property, if you drop from the center, this will be 90. And this two will be equal because these two are the radius. Very, very useful property, keep in mind. So what you are getting is a kite, and adjacent sides are equal. This two and this two are equal. So one more point is, if you drop the diagonal, okay, one diagonal is a perpendicular bisector of the other diagonal. So this and this are equal. So this is also going to be very useful. Okay, so what you got from this external point, you got a kite. From that, you know these two are equal, these two are equal, and these two are equal. Now if you are getting at least one, it is going to be very easy for you. So just keep this in mind. So here the diagonals are angle bisector as well as perpendicular bisectors. Okay, so we will see that. So let's suppose you get a question like this: 3 points outside the circle. Okay, one here and one here and one here. So something like this. Okay, 3 points you got outside the circle. What do? You can drop the tangent. So basically I want you to join this point such that it touches the circle. Okay, so I have given you 3 points outside the circle. These are the 3 points. So the moment you see 3 points, you join them, and what you get, you just combine it with the radii. Okay, so here you have the radius, you just join with the radius. You are actually getting 3 kites, right? So in this 3 kites, you know these 3 are anyway equal because that is nothing but the radius, and this 2 will be equal, right? This 2 will be equal, and this 2 will be equal. And now if you use the diagonals are the angle bisectors. So if you take this diagonal, this angles will be equal. Then if you take this diagonal, this angles will be equal. Okay, then if you take this diagonal, this angles will be divided equally. Now if I give you a question like this, okay, if I am giving an angle, okay, just this angle I am giving, let's suppose 30. What you can do is, this is 30 which is given, and you know this is 90 and this is 90. So this two together is 180, and this kite completely if you take, that is 360. So 360 minus 210. Why 210? This two is 180 and 30. So you get 150. I hope you understood this, right? So from that, how will you find? See, if you take like this is given 30, we know this is 90, we know this is 90, so you got this as 150. Then what is asked is, I can ask you anything from here, right? So this total is 150. So if I ask you this angle, this two angle together, so basically one from here and one from here, what is your answer? Now then what is this angle? This angle will be 210 because this entire should be 360. So this 210 is basically this 2 and this 2, right? So 2 kites are involved in that. So we know this will be equal and this will be equal. Let's mark these two as x and this as y and this as y. So basically 2x plus 2y is equal to 210. So x plus y is equal to 105. So what is this angle? This angle, that is 105, which is supposed to be a very difficult question, but you can solve just like that. So what is given? What is given is this angle only, 30. And what is asked? This angle is what asked. What is that? 105. Now another important property is, you have a circle. Okay, so let's take 2 points. What are the 2 points? Like these 2 points, let's mark it as A, B. So this AB is called as a minor arc. Okay, minor arc. This is called as minor arc. The opposite one is major arc. Now the angle inscribed in the minor arc, if you take 2 angles, okay, so this is one angle and this is another angle, these two will be equal. So if this is C and this is D, angle C equal to angle D. Why? Because these are the angles inscribed in the same arc. Now in the same situation, if you take a different scenario like this, see again, let's take a minor arc. Let's mark a point here. So you got an angle here. Now let's join that with the center also. Okay, so this ratio, if this is theta, this is 2 theta. So if this is AB is the minor arc, and we call this portion, okay, as measure of the arc. Okay, this is measure of the arc, and this is the angle inscribed in the arc. So what is the ratio? Measure of the arc and angle inscribed, the ratio is 2:1. So if one is theta, the other is 2 theta. Now another property is, let's take a same situation, AB. Okay, AB is the minor arc again. Now let's take another angle inscribed in the arc. Okay, let's take this C. There's an angle inscribed in the arc. Let's mark it as theta. So this angle is theta. Now if you draw a tangent touching this point, this angle will be theta, and this is what we call as tangent secant theorem or secant tangent theorem. So this AB is the arc and C is the angle inscribed in the arc, and if you join this tangent, so basically the theorem is angle inscribed in the arc is equal to angle between the tangents at that point. So this angle is theta, so this will be theta. So if this is given, you can find this. If this is given, you can get this. So that is a relation. Okay, so these are the important properties, and when it comes to circle, we'll discuss more of that. So this is enough to solve some questions that we are going to discuss now.